Okay. Thank you everyone for introducing yourselves, and I'm just going to scroll through and just take a quick look to see what type of experience folks have. Sounds like people are looking just to learn about irrigation for their vegetable gardening. Jen and Wedgwood mentioned container gardening and landscaping. My focus will be on veggie gardening, but I will touch on those, and everything you learn will be absolutely relevant for those applications as well. Where to get parts and materials, we'll definitely talk about that. Another, Barbara is interested in garden and containers, so I'll maybe focus on that a little bit. Some folks, Katrina and John in West Seattle, hoping to learn about the basics. Hook them up to rain barrels. That's going to be a little more complicated, so if I forget to mention that, I'll try and keep that in my mind. But there are ways to connect drip irrigation to rain barrels or cisterns, but they can be a little more complicated, or a little more, you might need some special parts or work with somebody who has experience with that, because it's just a little more complicated. Another thing about rain barrels, so some people are interested in raised beds, and yeah. Okay, great. Well, I think what we're going to talk about tonight, it is meant to be an introduction for folks who are maybe pretty new to drip, or have maybe tried it but aren't successful. And it should leave you, again, feeling fairly confident about how it works, what you need to know, what you need to buy, what you need to do, where you might need more information. I think after you take it, you should hopefully feel ready to maybe even this weekend go out and buy all your parts and get started. So, all right, I mentioned this before, but these are the handouts. And so you see the one is your sort of design guide afterward, and then the parts, and I'll send those out again, or send us an email if you didn't receive them for some reason. What I'd like to start with now is really just going over what is drip irrigation, because it can mean different things to different people sometimes. But at its most basic, as you can see in this picture, you're really looking at these plastic lines, and those lines have little holes, which are actually emitters that are inside of them that are slowly releasing water to plants. So at its most basic, it's not that much more complicated than a hose. It's water going through a plastic tubing, and then it's a special way that it gets released so that it's very consistent, and then it's just a matter of how do you lay it out, how do you connect it, what are some of those other special parts. This is another picture of drip irrigation where you can see it's been turned on, and so there's those darker circles, and that's where the drip emitters are emitting the water. And below the soil, you're actually going to have even more coverage. So it might only look like you're watering up these little patchy circles, but underneath where your plant roots are, the water is traveling through the soil. Here's a quick picture, and we'll talk about this more, where you can just get a sense that there is more water flowing through by gravity and capillary action, getting at plant roots, although it does actually depend on what type of soil you're working with. And this is a close-up of a very typical emitter. This is in drip line, where it has these sort of built-in emitters that trickle out water. And this is actually the type of drip irrigation that I recommend for containers, for veggie gardens, even for landscaping, only because it's fairly simple, it's straightforward, there's not a lot of extra parts and pieces, and it's very flexible and adaptable, which you'll see going forward. But there's a lot of other types of parts, and maybe that's a great thing to emphasize now, is that because there's whole catalogs and companies. I'm just taking a pause. Can folks still hear me right now?
I can hear you.
Just putting that in the chat. I got an audio alert. Okay. I think I'm just going to pause now and switch over to a different microphone. Yeah, I'm using a Bluetooth, and sounds like Okay. Can folks still hear me now? Okay, thank you. Sorry for that. Go back to where we were. So I think I was saying before I got interrupted by myself that there's a lot of different types of drip irrigation parts out there. And it can be confusing sometimes when you're trying to figure out what you need or what you want. And everybody has their own preferences, and there's just a lot of choices out there. So if you're really excited about drip irrigation, then go ahead and explore those. But it can also be overwhelming, and they can cost a lot of money. And quite frankly, some of them just don't work very well. So just be a little wary before you just dive in, because there's a lot of people with companies out there trying to sell products. So that's a factor too, to consider. Here's just another picture. It's a little micro sprinkler. Some of them, as you might imagine, are actually not very efficient in watering as well. So there's a whole world out there. We'll cover the most common types. The reasons why you might want to use drip irrigation, the benefits, mostly I think about the fact that it is a very efficient way of watering. So you're definitely going to cut down on your water bill. It's going to take less time to water. It's going to provide water directly to your plant's roots in the soil. And when you avoid overhead watering, you can actually avoid certain plant diseases and spreading them. And so it's also makes for healthier plants. And then I think the reason that many of us think about drip irrigation is because it has the potential to run on a timer. So you can set up a schedule, and then you don't have to remember to water every day, or you can, don't run out in the morning and have to water. You can have your cup of coffee and let it do all the watering for you, or take a long weekend, go on vacation, and know that your plants will still be getting watered. And that's a great reason to think about drip irrigation. There's some considerations why it might not be the right choice, and I have this image here because it's just an example of some of the parts and pieces that are involved, and it can just be a little overwhelming. It can be a lot of plastic for people to use if you're trying to avoid plastic or make different choices. I will say that a lot of drip irrigation, even though it's made out of plastic, it can last for a long time. Some of that tubing and supplies will last for many years, so it's not like a disposable single-use plastic. And they're designed to not degrade as quickly as like a hose or other types of plastics that don't last as long. So they are meant to be used for these purposes. But they can be, it's an investment up front for sure. So you might need to think about that as well. I would say it really varies, but if you're setting up, say, 2 or 3 or 4 garden beds from scratch, you might be looking at $100 to $150. But each additional bed is not going to cost a lot of money, because a lot of that is just some upfront components that you need for any system, and then adding on to that doesn't cost as much, but it might be a calculation you want to make for yourself. Another consideration, this is the planting strip actually in front of my house, and I have installed drip irrigation here, but I had to go underneath that sidewalk, which I'll actually talk about how to do that. But just know that it might not be right for your setup. If you have, depending on how your beds or landscape areas are set up, drip irrigation is meant to be ideally an above ground system, not buried in the ground. And so in many garden settings, people lay it above the soil and cover it with wood chips so you can walk on it. But if you have a big lawn area or driveway you have to get across, you do need to think about, is there a way to get tubing either to snake along the side of that, or potentially you can dig a small trench, put in some PVC pipe to protect it, and run it through that. So and we can maybe talk about that a little bit more if folks, if that comes up and want to share your situations. But just know that you do need to think about, where are these tubes going to run? Where is my nearest water spigot? If you have significant changes in elevation, meaning more than about 20 feet or so, it might not be a good choice, or you might have to do a little more troubleshooting to make it work. But other than that, it really is appropriate in most garden settings. Here's a picture of where you can't really see it until it's in the beds, but it's underneath that wood chip mulch. And so that's a kind of a recommended strategy if you can for garden settings, just because then you can just scratch away the mulch, take a look at it, make sure there's any problems, rather than having it buried in the soil. And then if you are using it for landscaping, and if you're choosing native plants to the Northwest or plants that are adapted here, once they're established, they really don't need much, if any, supplemental watering, except in the worst droughts. So you would want to decide whether it's worth the time and the money and the effort to irrigate your plants if they can potentially be just fine on their own. I know with climate change, it's getting to be the point where a lot of native plants are actually struggling, so that's also something to consider. But typically, applications like veggie gardening with annuals or containers, because they dry out so fast, those are definitely going to be good choices for drip irrigation. Landscaping, you might just want to think about it a little bit more. So we're going to move into now thinking about how do you actually make a design for your own yard or balcony or whatever situation you have. And to do that, I want to just take a little bit of time and talk through some of the basic parts you'll be needing for those. So this is just a picture of your handout you have, and we're going to go through this one by one. But to start with, the most basic part of setting up your drip lines are to run what can be called supply line. Some people call it main line, tubing, blank tubing. Unfortunately, a lot of drip irrigation has many names for the same parts. And so just depending on the store or who you're talking to, you might hear different words for the same thing. But in general, this is just plastic tubing. It's solid. There's no holes. It's just kind of like a hose. It's just to supply water from your spigot to your beds or your planting area, but where it's not actually providing watering as it gets there. The most commonly used type in home settings is 1/2 inch, which is the size of the tubing, supply line. They also make 1/4 inch, which is typically used maybe to get around containers or in more delicate areas where having a larger line just isn't very helpful. Then the next, it looks similar, but it's called drip line or emitter line. And that looks very same. It'll be either a 1/2 inch or a 1/4 inch. But that actually has the emitters in it. And so that's releasing water wherever you put it down. So in a typical setting for, say, a garden bed, you'd run a 1/2 inch supply line. And then when it gets inside the bed, you'd lay down 1/4 inch drip line emitters. They do make 1/2 inch emitter line, which is a bigger kind of emitter line. And that can be useful in landscaping sometimes. But generally speaking, you're using 1/4 inch drip line. It's just easier to work with when you're in beds. All of those 1/2 inch pieces you might need to set up for a couple beds, and so you need to make a T and branch out to them, and we'll see pictures of all this. And just know that they're just plastic. They're kind of like adult Legos. So there's elbows if you need to make a 90-degree turn, and a T if you're splitting it off. A coupler, you need to connect 2 pieces, and then there's these end caps, which are what you put on at the very end of the line so that the water itself stops flowing. And they have a fancy kind that you can screw and unscrew, and then a figure 8, which we'll show in the video what that looks like. Go a little further, and then I'll get see there's some questions, so we'll go to those. This is just showing in an actual setting where you would use these fittings. So you can see somebody wants to put irrigation in their raised bed, so they have the supply line that comes to a T, so they can you literally just cut the line and put it into the T, and then at where the T then goes into a new line, and then that itself they have to cut again and put an elbow on so they can make a 90-degree turn. So that's typically how you're using
those types of fittings. And the same information, but just showing it from more of a design perspective, where you would lay out your lines. Once you have a sense on your design, then you would add in, oh, okay, it looks like I need a T here because it's going to the bed. And then I need an elbow here because now I'm turning 90 degrees. And then at the ends of the 1/2 inch supply lines that are supplying the water, this image is using what's called the figure 8 end cap, just a way to plug up the line so that no water comes out at the end. The exact same type of fittings exist for when you're working with that smaller 1/4 inch line. So in that case, you have your own, like a smaller version of an elbow and a T. And then a transfer barb is kind of a funny name, but that's what you essentially punch a hole in your supply line. And that transfer barb is hollow. And then the 1/4 inch drip line with water coming out uh, connects on one end of the barb, and then the other end is in your supply line. And that's how the water actually gets to those emitters. So we'll see how you put that together, how it works. And then when you have the end of your 1/4 inch line, instead of using a cap, they actually use something that the technical term is called a goof plug, because you just kind of plug up the line, or if you accidentally use a punch and make a hole in the wrong place, you can use those to fix your goof as well. So just to see those in action. And this is for those of you looking at containers, a good example. On the left-hand side, I have 1/2 inch supply line running the length of the deck. I used a 1/4 inch barb to connect into that 1/2 inch line with solid 1/4 inch tubing, and that runs up the back of the container, so no water's going anywhere just yet. Then I used a few different 1/4 inch elbows so that it went into the container all nice and pretty. And then once it's in the container, you have drip line in that container. So that 1/4 inch line in the container, it has emitters in it, and that's where the water is coming out. And I've plugged it up with a 1/4 inch goof plug at the end of that line, so the water doesn't run out. In a garden setting, you would use the 1/4 inch transfer barbs each time those drip lines connect to the supply lines. You'd use the 1/4 inch goof plugs at the end of each of those smaller drip lines. And I'll just point out at this moment, and then I'll answer some of these questions. This is a picture of a kit. So if all these pieces and parts is already feeling kind of overwhelming, one, maybe sit with that and let it pass. It really isn't super complicated, but they sell these kits and they will come with a lot of the basic parts for what you'll need in a typical bed setting. And hopefully by the end of the class, even if you decide to just buy a kit because it has everything in it, you'll know if there's anything else you might need to just supplement that. So let's see, a couple questions came in. One was from Katrina: is surface tension an issue? Katrina, feel free if you want to add more, either unmute or type in the chat box. But I think maybe if you're wondering about maybe the size of the tubing or how that affects water getting to your water flow, things like that, we'll go over some guidelines for how sort of big the capacity should be for your drip system, so that you don't have to worry about, are all my beds being watered the same? Or the plants at the far end of the line being watered the same? There's some general guidelines for that. As long as you stay within those, then you shouldn't need to worry too much about that. And it's also true that if you use the larger size tubing, they also make a 3/4 inch tubing, even larger, you will have more capacity for your system. So instead of being able to water maybe 5 beds, you could water 10, because your tubing is larger, so there's the water and the pressure and everything is working better together. So hopefully that answered your question, but if not, we can follow up more. And then Sarah asked, can I drill a hole in my raised bed and have it go on the inside instead of coming up on the outside? That's actually exactly something you can do, and I have a couple pictures of that later on for working with raised beds. Okay, so I'll continue, but if you, again, have any questions just about what we've covered so far, about the components, things like that, feel free to type those in the chat. And I think somebody had asked earlier where to buy all these pieces. So these days you can find drip irrigation supplies at any of the regular hardware stores, Home Depot, Lowe's, McClendon. If you shop online, really my favorite online shopping place is DripWorks. They have a very easy to use interface, pretty good customer service. And I just find them very easy to work with, and they tend to only carry they're focusing on home gardeners, so they sort of curate what they supply, whereas other stores online, like if you were to just do drip irrigation supplies and see what came up, sometimes maybe they're working with plumbers, or they're just working with a different audience, and sometimes it's harder to find what you need. So Katrina is I think clarifying what is recommended max length, and does it differ for different diameters? So just see so that's actually a good segue, because we're gonna start looking at this design. But at a certain point, you do need to think about, like, how long can I run that supply line? So if your garden beds are too far from where your water is, then you just won't be quite as sure that you're having this the amount of water that you think you're having coming out. And so the standard length to think about is about 200 feet for half-inch tubing, which is what most folks would be using. So if your water source is more than 200 feet from what you're watering, then you might need to see if you can come up with a different system, or just know that maybe it's not going to be 100% consistent as you'd like. It will also show how to measure your own individual home's water capacity, which answers that question as well. Within a bed, say you're using that smaller 1/4 inch drip line, usually up to about 20 feet for each of those lines is fine. If you go further than that, like you want to have a 40-foot long bed for some reason, and you're using 1/4 inch drip line, then you're probably not going to have as even watering along that line. And they do make specialized emitters that you'll see the letters PC, standing for pressure compensating. They're more expensive, but they will be able to overcome a lot of those difficulties. So Terry was saying, just to confirm, so for the 1/4 inch drip line in your garden beds, try and stick under 20 feet long. So you might have 4 different drip lines that are each 10 feet long, and that's fine. It's just not less than 20. So and if that was confusing or way over your heads at this point, don't worry, it'll still make sense. But those are great questions. And so this is a picture. You don't have to draw anything super fancy, but this is just an example of where you want to start when you're thinking about your drip. And start by drawing all the things like the road, the sidewalk, where your house. This blue circle is where my water spigot is. And then I have those sort of rectangle-y beds to the right. Those are 4 garden beds. I also have some blueberry shrubs. You can tell from those little blueberries along the road. And right in front of the house, there's 2 beds where, say, I have raspberries. So basically, it's just showing that there's a lot of, you want to draw out all the different planting areas. I added containers kind of in the bottom right, those little green circles. Draw out where you have garden beds, where you have containers, where you have different types of plants like perennial plants or other areas, so you have a sense of that. And then any sidewalks or pathways, things like that. So then the next step that I'm going to do is just start drawing out what looks like a reasonable way to get from my water to my beds. And so this picture here is just showing, okay, I want to water these 4 beds. So I'm going to draw what will eventually be my supply line there. I might think about watering my blueberries. So I'll just draw that out. see what that looks like. And I'm not necessarily going to install all this in one go, but I'm going to try and think toward the future in case I do decide to water multiple areas in my yard. And then I thought, well, I might as well hit those beds too on the way. So now I'm kind of adding that. And if I was really ambitious, I might decide I want to also water all of my containers. And as you can already start to see, it's starting to get quite a bit complex. And so I would say, again, think about the future, because if you design the system to be flexible, then you'll be just in a better place. But also, it really is easiest to maybe stick with just one of those areas first, and not try and do all that at once, because it'll probably be overwhelming, and you'll have some challenges. And again, this is a time to do some of those initial thoughts about, I'm noticing if I do the blueberries, I have to go across a sidewalk. So I'm gonna have to think about that more. And I'm gonna think about, are my beds 200 feet from my water source or less than that? So I'm kind of just getting a sense for that, to think what might be feasible. For right now, and maybe for your first time, I'm just gonna say, I'm gonna start with I just want water to these 4 raised beds. So I'm gonna focus on that. So what I would then do is go ahead and measure how much tubing that is. So you could go out with a tape measure or estimate if you feel pretty good about that. But all it's saying is that it's about 75 feet of tubing to go from my water to those 4 beds based on what I sort of drew on my map. That's not actually that much tubing. Tubing comes in rolls of 50, 100 feet, 500 feet. It's fairly inexpensive. So my first step, I'm just putting out those. Then I'm thinking more, well, I have to also get the water in the beds off of that main line. So I added an extra 25 feet or so. So now I'm looking at needing about 100 feet of 1/2 inch. This is the solid tubing. Then I am drawing on the drip line. So again, that's the line with the emitters in it. I'm using 1/4 inch drip line, and I was able to tell that I'm going to need 128 feet because I've done measurements, and I know my garden beds are about, say, 4 feet wide and about, say, 8 feet long. And typically drip line, when you buy it, those emitters are spaced, the most common spacing in between each of those emitters on the line is about 12 inches. You can also get it in 9 inches or 6 inches, meaning you have more emitters on each line. And we'll talk about a little bit further on when you might decide to use what type of spacing. But as a sort of a general rule, 12-inch spacing is fine. And the emitters are spaced 12 inches on the line, so I want to space my lines also 12 inches, so that sort of in all directions, every 12 inches there's an emitter. And so that actually tells me that in each bed, since they're 4 feet long, I should fit 4 drip lines. So I have 4 lines, each one's 8 feet. So in each bed, that's about 24, did my math right? 8 times 4, 30, 32. That tells me how many feet of drip line per bed, and then I multiply that by 4, and that's where I got that 128. So I know about how much to buy. And honestly, I'd probably go ahead and buy like 150, just so I had a little extra, rather than find out that I'm too short. Once you feel pretty good about what you need for your supply line and your drip line, then based on your drawing, look at where you're adding elbows or tees or those other fittings where you know you need to make turns or split off from the main line. So in this diagram, I highlighted the 3 green circles, or where I can visually tell I'm going to tee off to go to those beds. And then some of them, I'm going to need more elbows to help make those tight turns. There are times where you can just sort of gently curve the tubing and you might not need an elbow. So you can either buy a few extra just in case. They cost about $1 each or so. But at least I'm getting a sense for how many fittings I need. And then I'm going to add, I need 4 end caps because I have 4 beds, and the supply line for each of those needs a cap on the end. So I've kind of laid out that. And then I'm kind of going further, and now I'm trying to figure out, well, how many of those small 1/4 inch fittings do I need? And since I have 4 beds with 4 lines in each bed, I know I'm going to need 16 of those barbs to transfer water, and then 16 of the goof plugs to plug the ends. And then those smaller parts, they usually sell in small bags of like 10 or 20, and they're pretty inexpensive. Definitely buy more, especially the goof plugs, than you think you need, just because that can definitely come up. Looks like there was a question from, I think, Laura, that I know I need more elbows than I had put on my bed. So just to, oh, okay, I think I know. In this diagram, I'm just assuming these are in-ground beds, meaning that I just need 1 elbow to get into the bed. So if I were doing raised beds, you would need more elbows than that, which you'll see if that doesn't make sense. So okay. Sorry, I know this yeah, drip irrigation can get confusing or overwhelming, but yeah, hopefully this is kind of making sense. And this next thing also can get a little overwhelming. It's all doable, but it might be new. It's good to understand how much water flows when you turn on the spigot. And so that's called your water capacity, which, you know, it means if I turn on my spigot at any given moment and run it for a minute, how many gallons of water is coming out? That is another piece of information to tell you how big you can design your system, how many beds. Because if your system gives you, say, 100 gallons per hour, and you're trying to run something that really needs like 1,000, then you're going to run into a lot of trouble, and you're not going to have the water capacity to run that much. And so when you're using those drip line emitters that inside the beds, each of those little emitters is typically releasing a 1/2 gallon per hour of water. And so you can actually calculate how many gallons per hour of water your system will use at one time, and then figure out whether that is under or beyond your how much actually comes out of the spigot. So for example, if you had those raised beds with 4 drip lines and each drip line had 8 emitters in it, because they're spaced a foot apart, the beds are 8 feet long, that's about 24 emitters. And if each of those 24 emitters is releasing a 1/2 gallon per hour, then that's 12 gallons per hour of water needed to run water for that bed. If they were 1 gallon emitters, it'd be 24 gallons per hour. So if you had 4 beds at each one using about 24, we'll just call it 25 gallons per hour, that's about 100 gallons per hour. And the rule of thumb is, regardless of your water capacity, anything more than about 200 gallons per hour that you're trying to run, you might start to experience a lack of consistency. But I would sort of temper that with figuring out what your actual water capacity is, how much water actually comes out when you turn on the spigot. It's really easy to actually measure that. You take a bucket that you know how big it is. It does not have to be a 5-gallon bucket, but those are pretty common and easy to find. And then all you do is turn on the spigot full blast and see how long it takes to fill. So in this example, you just take your 5-gallon bucket, and it took about 50 seconds to fill it right to the top with water. So to convert that into gallons per second, you just divide the 5 gallons by the 50 seconds that it took, and you get 0.1 gallons per second. And this math is all in your handout, that design guide. So if this kind of math scares you, you just have to plug in the numbers using the formula for you. Once you have gallons per second, you just multiply it by 60 seconds to get 6 gallons per minute in this case, and then by 60 minutes to get gallons per hour. And so this example was 360 gallons per hour. So that's telling me that my water system can provide 360 gallons per hour. And so if my emitters were running at a ½ gallon per hour, then I could run 2 times 360 gallons per hour of emitters. So that's 360 is bigger than 200. So if I were using that information for my plan, I'd say, well, rule of thumb is not to go over 200 gallons, but my system says I can get about 360. So if I were having a system and it was big enough, I might be fine going up to 250 gallons per hour of emitters, or maybe push it and go to 300. The reality is that it might not be consistent, but we're also not consistent if we're watering by hand. So it's probably still going to work better than hand watering anyway. So don't be too afraid, but also be aware that there are limits for how much you can run with drip irrigation. So that's the water capacity. I am going to give us a chance now to just take a break to digest some of this and then put it in practice by drawing your own system out. So I'll go through this and then I'll also answer some quick questions, anything that's kind of burning that has come up thus far. But what I'd like you all to do, and we'll take a little bit of break here, is to, if you haven't already, sketch a map of your planting area you're thinking about. Figure out where you want to start for this year, or maybe you've already started. Draw in the supply line, the ½ supply line, and then the drip lines, emitter lines. Add in those fittings. You'll be able to create an inventory of what to purchase, and then maybe not in the next few minutes, but when you have time, take the actual measurements to know, see what your water capacity is, and then we're going to talk a little bit more about the next pieces, which are the head assembly components and the tools. So before we break, if anybody has anything that's just super unclear, you're uncertain about, feel free to type that in the chat and I can answer that. But otherwise, it's about 6:41. So let's come back, we'll say 6:49, give you 8 minutes. So go ahead and work on this and then we'll come back together. I will answer Barbara's question here because I think it could be really relevant for folks, which is how far apart the spacing should be for emitters. So if you're using drip line, they come pre-made, usually with 12-inch spacing. You can also get 9 or 6-inch spacing. If you're using other types of emitters, then you place them sort of around the plants, essentially where their root zones are. And then Renee has another good question about 200 feet of ½ tubing. That means all the tubing that is running off one spigot. The 200 is the longest length. So if you have, you don't necessarily need to worry as much about when you're splitting off and branching off to different beds. It's really more if you have, it's really just 200 feet of length before you even start doing your drip irrigation. That's when you need to start being worried about that. And if you do have more than that, then you can either set up a second zone that you might have another timer for or another system, but you're gonna have to come up with some way to work on that. So I'll answer this last question and then I don't wanna distract you from your endeavors, but there's a question about spacing. If your veggie beds, your plants don't need to be evenly spaced because drip irrigation is really watering the soil and it's allowing you to maximize the roots that are absorbing water in the soil. So if you're in a landscape setting and you have like a plant every couple feet and you really just want to water that one plant, that's where you might think about other options. But even in a veggie bed that's sort of random, it's generally good to just have consistent, even watering for that whole bed, because the plant roots are going underground, sometimes a foot or 2 feet, and so you really want to water around those, water consistently in that space. And but yes, if you're, you know, watering a shrub here and then a shrub there and a plant there, you can punch in and buy an individual emitter just for that one plant. But in veggie gardening settings, you almost always want to use the consistency of drip irrigation, drip line for that. So, okay, so I'll let y'all continue, and I'm going to take a break as well. Okay. Hopefully that gave folks enough time to at least kind of work on that, take a little break. I would actually like to ask if anybody is feeling brave and has a design they feel comfortable maybe holding up to the camera and maybe talking us through kind of what you come up with or questions you might have. So does anybody feel brave or use it as a great chance? It doesn't have to be all right. It's okay. But maybe mention in the chat box there or unmute yourself and just jump in. Looks like,
I'm happy to try it.
okay, let's go. That's Barbara, it looks like.
So I've got a big garden in the backyard. It's about 27 by 17 feet, but there's only one space that I want to actually do something. And so I figured out, can you guys see my lines?
Kind of see that. And if folks can click on speaker view, I think if it's not showing up for you, but okay. And
So I actually have 3 spigots in the backyard
oh, you're lucky.
because we have a double lot.
Okay.
So we have a large backyard. I have a big rhubarb plant right in the middle of the garden. And so I am going to be sending out 7 rows, about 16 feet each.
Okay.
And they're going to be spaced. I'm going to do the 12-inch spacing, but they'll be about 2 feet apart. So
Okay.
hopefully that'll work. Right now I've got my rows totally in a different way. And I know that you take this out every year, so I guess it's not going to be an issue if I want to rotate my crops next summer.
Yeah.
Um,
No, that's thank you for sharing that. That did make me realize I should point out that in fact, with drip irrigation, you leave, other than the part right at the spigot, which we'll talk about, you leave all the lines in place year round. So you can move them, the 1/4-inch lines if they're in your beds, to move them aside to work in the bed. But typically you actually don't have to, pull things up and take them away.
I will, since I turn my soil and
Yeah.
add amendments every year. So
Yeah, so in most cases, again, it depends on your setup, but if your veggie bed has the 1/2-inch line with the lines coming off of it, you can sort of just swivel them aside, and then you can work in the soil as much as you want. So,
okay,
but anyway, obviously however it works in that setting. So
great.
cool.
Good to know.
Thank you for sharing. Anyone else feel inspired to share theirs or just ask questions that came up for you? I'm happy to take a moment here. And if not, I will just check. There were a couple questions that came in, and Andrea was wondering about coordinating drip irrigation with inconsistent rainfall. There's super fancy timers where they have rain sensors and they can sort of adjust accordingly. But for the most part, you just have to kind of keep an eye out. And often, even basic timers have just a little button. You just run out there, you push it when you know it just rained or it's about to rain, and then it'll set in a rain delay for like 24 hours or what. You can actually tell it for longer. So it's a really easy way of sort of pausing the system you have. But otherwise, yeah, you basically keep it fairly consistent. And I know this June we had really dry weather, and now it's gotten back to a lot more rainy, and it's kind of thrown things off. Let's see, another question. Can I attach the ply line to a hose? That's a good question. People will do it. The reason why you might not want to is that hoses, they really don't last as long compared to the drip tubing. They tend to degrade a lot quicker. They don't hold up quite as well, and it can be a little tricky to it can be easier just to connect the drip right from the spigot. And the supply line is incredibly cheap. So 50 feet of supply line is very, very inexpensive. And so if you have an old hose, you might as well get more value out of it as a hose. But I totally see that happen. I have probably done that myself from time to time. You can integrate a hose into the system. One question about you recommending 1/4-inch soaker tubing. So we will at the very end, I'll touch on soaker hoses a little bit. They don't do as good of a job as drip emitters. They're not consistent. You have no idea how much water is coming out, and they don't hold up as long. So I guess I don't recommend them strongly, but they're also pretty simple. And so if you're looking for a real simple solution, then soaker tubing can be an option. It's not going to last as long or work quite as well, but might be better than hand watering. So there's a question about handling irrigating plants with different amounts of water. We'll sort of touch on that a little bit later on, how you care for different plants' watering needs. And then there's a question about if I split my spigot, does that mean water capacity would be halved? So we'll talk about that too, but if you have what's called a hose Y, where it splits, you're right at the spigot, when the water's running, that shouldn't affect it unless you're running both water, like your garden hose on one end and your system on the other. So usually that's not going to have an impact for that system. And one more question here from Amy about a vertical garden tower. Sounds fun. That I water at the top, which is about 5 feet high. Going up 5 feet shouldn't be a problem. Usually, again, the general guidelines are about, they all have 2s in them, maybe because it's easy, but about up to 20 feet in change in height throughout your system is usually not going to affect the performance of how the watering happens. So if it's not too much height, then that should be fine. Okay, so I'm going to go back to the presentation now and go through a little bit more, and then we're going to watch a video of the installation and see where that leaves us. So at your spigot, you need to, unfortunately, buy a bunch of different things that are maybe brand new and confusing, but they're really not anything technical. They might just be unfamiliar. So in this picture, this is what your handout has. We're just gonna go through it and talk through what they all are. So what I would recommend in any setup is to use what Laura, I think, just mentioned, a hose Y, a hose splitter, a connector. This is just a valve that lets you use 2 different things depending on what you want to use at your spigot. So for those of us who maybe only have 1 spigot, you might want to have a garden hose for one sometimes and then your drip on the other. So installing one of these makes a lot of sense. They even make them with the 4-way, so you can get really complicated. Definitely a good investment. And then after you attach the splitter, so this is an order of how to put these components. It's not required, but I recommend a quick connect. I haven't used those before. They just make it so you can take on and off whatever you have attached very quickly. And I'll show that in the video, but that's only because these components on the head assembly that we're talking about right now, those you do need to take in the winter so they don't freeze. And if you don't have a quick connect, you have to manually loosen them, and it's just a lot easier if you have a quick connect. The next piece you normally have in a typical drip irrigation setup is a timer. So on the left is a simple crank timer. You just go out there, you crank it. You can't program it, but it also means you could be doing other gardening tasks while the watering is happening. In the middle is a more common timer where you can sort of see, it lets you tell it how long to water, how often, like every day, every other day. And then the other timer here is where it has, those 2 sort of ports on it. That's when you're getting into situations where you might need to water 2 different zones, either because they have dramatically different watering needs, or you've hit your system capacity and you need to alternate when you're watering. So talk a little more about that. I did see a question come in from Terry. And just to confirm, yes, when you use those HoseWise, those little black knobs let you turn on or off which one's running at one time. So you can just adjust which one you want to run while the system's going. So hopefully that made sense. After the timer, you want a little thing called a backflow preventer. It's required by code. All it does is, in the case like they're accessing a fire hydrant, it can sometimes pull water like a vacuum through your system into the water supply, so the water's going kind of backwards, and they just don't want any potential for contamination to come from your garden into the municipal supply. There's almost no chance that would actually happen in a drip irrigation system just based on the laws of physics, but it's required, not a bad thing. So backflow preventer. Then you have a filter, and they look kind of funny, but they have on the right, you can see this sort of a mesh typically inside, and that is filtering water from the city, your water source, or well, I suppose, or wherever you get your water, so that if it has any contaminants and particles, that they don't clog your drip system. So the filtering is happening before the water goes to your beds. It's not filtering anything from your beds. Something you clean out once a year or so. And then you have the pressure regulator or pressure reducer. This is super important. Most people, your home water pressure is probably 50, 70 pounds per square inch. It's typically very high, likely higher than it should be for your pipes. This is bringing it down to like 20 or maybe 15. For drip irrigation, that's the correct pressure. If it's too high, the system is gonna be like little sprinklers instead of drippers. It'll break, it'll leak. If you're even using a soaker hose, you should actually have a pressure regulator to make sure it's having the right kind of pressure. If you have a very low pressure system, then you have a different problem to solve. But almost always you're going to need to install a pressure regulator. All of these components are actually fairly inexpensive, other than the timer. It can be a little pricey, but you do need to kind of know what you're looking for. And then the very last piece is what actually connects from all of that to tubing. And so on this picture, you can kind of see on the kind of the left-hand side, you can see where the hose thread would sort of fit in on that. And then the other side is this hollow, and you typically kind of jam the tubing just right in there. And it has these little barbs on the inside that hold it in place. That's the most common kind of a hose start called a compression fitting. There are other ones to work with that you sort of that work a little bit different, but that's the kind of common one you'll see. I do want to make a point if you're like going to the Home Depot or wherever to pick these up, make sure you're buying things that are hose thread. Unfortunately, most of these parts come in hose thread or pipe thread. Almost everything in a typical drip system is using hose threading. As on the left, you can see it's a little wider or spaced out more, and on the right is pipe threading, which is used in more types of plumbing applications. Things are labeled. Typically, they'll say, for example, MHT, which is male hose thread, or FHT, female hose thread. So if you see that little H, that's a clue that it's hose thread. Sometimes people will pick up parts and put them in the wrong place. And then you get home and you try it out and you wonder why it's not fitting, why it's leaking. It could be because you accidentally got a part that uses pipe thread instead of hose thread. So just be aware of that. And then every time you put on these fittings, you're going to wrap Teflon tape or plumber's tape around, and that just helps fill in any little gaps and prevent leaks. It saves a lot of, I think it's one of the most important things to do when you're putting together that head assembly, because you often do get leaks, and using Teflon tape almost always solves the problem. And we'll see that in the video. So I'm going to go ahead and jump into this video, and you're going to see how a typical installation will work. So I'm going to pause the sharing here on that PowerPoint and load the video. I'm going to narrate over it. And before I do, just make sure. So there's a comment from Renee just about water pressure, buying cheap pressure regulators. Yeah, so sometimes it's worth to not go too, don't go too cheap on those head assembly parts because they just don't work as well, and I think that's a good thing to consider. Okay, so here goes the video. So I'm taking those head assembly components. I have the quick connect, and I'm wrapping Teflon tape around it, and you wrap it in the direction that you're going to eventually sort of turn that piece. So usually that's clockwise, and that way it goes with the threading, and it just works better. And so I put that around. Next is the timer, and so that goes on the quick connect, and you can see I already have Teflon tape on the other end of the timer. So each of these components, you wrap Teflon tape. After the timer, I'm using the backflow preventer. So you tighten that, wrap more Teflon tape. Next is the filter. Looks kind of like a ray gun now, or a water gun or something. Again, add the Teflon, and then there's my pressure regulator. And so the last component here is the hose start. So that's what's gonna connect to the tubing. So I've gone from all this threading to now being able to work with tubing. So that's my head assembly. So you're gonna have to find a place for that whole thing at your spigot. And then here's how that tubing goes. It just goes right in there. You just kind of jam it in. It takes a little bit of work, but. And then here it is at a spigot. You can see I'm attaching it to my hose Y, just like that. And on the left, I have a garden hose attached. So when I'm deciding to turn on the other one, and that's how the quick connect works. Just go on and off, just like that. You can see I can turn the drip on and off, and then turn the garden hose. So I leave the spigot turned on at all times, and now I use those little valves. And those are what's turning the water on and off. So you're essentially leaving your water running all the time, and the valves are turning it. So I've now gone to my garden bed where I want to put in a drip line. And so I've decided I've laid out my supply line, and I now need to put in one of those tees. That's a picture of a compression tee. The one in my hand there is a little fancier there. Hopefully, somebody mentioned there might be something blocking the video, so hope it works well. Then you're gonna make a cut, and I'm just using pliers, or I'm sorry, pruners. Try and make a nice up and down straight cut. And then I make another one. And I'm just kind of guesstimating, so I'm cutting about the similar size as the tee was. And then with this type of fitting, you sort of put the tubing in over a little piece and tighten it. So it works a little different. It's called like an easy lock fitting. Easier to work with, but whatever you can find is going to work okay. So I've tightened that. These ones you can reuse pretty easily if you need to take it off and try again. And then I'm putting in the other side. And so now, this is a note that if you have a little thermos of hot water and you dip the tubing in it, it can make it much more flexible, especially if you're working on a cold day. The tubing takes a while to kind of warm up. So the thermos really does help. And now I'm looking at the garden bed, and you can see there's a tape measure for measuring how long it's going to be. But what I like to do is just take my larger roll of the supply line tubing and just use that. And here I am attaching it to that T that we just assembled. And I'm just kind of, without even necessarily measuring, just working with the whole length of the tubing. And then I know where the end of the bed is. So that just tells me exactly how long it needs to be. And I kind of line it up and then I cut it off. And here I have made the cut. And again, nice straight up and down cut. And I'm using a figure-8 end cap. And there's a picture of the regular end cap. But you can see with the figure-8, it's very cheap, very, very cheap. You slip it over, you bend the tubing and put it through the figure-8. And believe it or not, that actually is enough to keep the water from coming out. It's kind of like magic. So I've now capped that line. And so now I need to start with the 1/4 inch drip line. So my bed is 4 feet and I want to measure drip line every foot so that I'm evenly spaced. I'm using some sticks to help with that. So I'm coming in to start with 6 inches from the edge of the bed, putting a stick down, and then going a foot, another foot, and another foot, and then another 6 inches at the end. So basically I now know where my 4 drip lines need to go. I'm using a punch. This is the cheaper kind where I put my little stick and you just kind of push it into the tubing. It could be hard or easy depending on the temperature. Try not to punch through all the way to the other side. It can happen. And this one I think was a dole, but there is another punch tool that's maybe 10, 15 bucks that it's a lot easier to use. So if you're doing a lot of beds, I do recommend buying one of those. So I punched my hole. I'm now taking 1/4 inch drip line. So this has the emitters in it. And I'm going to grab one of those transfer barbs. So one end is going to go in the 1/4 inch tubing. Just kind of jam it in there. And they make a tool for that as well. Although I find that this isn't too hard. And then I'm putting it right in the hole that I made in the 1/2 inch line. I think my punch was a little dull, but usually it goes in pretty easy. And now I've connected that. And you could measure it ahead of time, but I'm going to go down to the other end with some goof plugs and my pruners and just kind of take the whole length, roll it down, and then figure out when I get to the end of the bed where to cut it. So I'm just walking down with that. If you do get a kink in any of these, they will fix themselves once the water is running. So don't worry if there's like a kink, you can work it out and it's not going to damage the system. They're pretty resilient. I'm pinning it down to get it nice and kind of straight. I found where the last emitter is, and the one with the arrow there is a little too far, so it's outside the bed. So I'm cutting after the last one that's in the bed. And then to cap the drip line, I'm taking a goof plug and I'm using the smaller end. The larger end can help if you have a mistake in the supply line. And then now that line is capped, and so water will only come out on the emitters, and then I'm using a little staple or a pin to keep it in place. Don't buy the plastic pins to hold things down. They don't work very well. So this is in fast motion, but just doing the same process where I connected the line, pinned it down, and went back to the start, and I connected it with a transfer barb. I'm trying to stagger where the lines start so I get more even coverage, and I can go back on that in a little bit, but just trying to have them start at different places, not all evenly. And so it literally only took me about 5 or 6 minutes to do all that. And I have a finished bed that has drip irrigation. So a lot of work in the design and buying the parts, but the actual installation was pretty straightforward. So that was the installation. I'll go back now to the PowerPoint. And I'm going to keep rolling here, and then we'll see if there's more questions that come up. We're getting close to all the information, and then I'll go from there. So that was the installation. In terms of your timer, what they're really doing is just determining the frequency and the duration of your system. So this is an example where you can literally see, you tell it what time it is, and then you tell it to run. Somebody's saying the gray box is back. That's the chat box. So let me try another strategy and see. Try doing screen share. Okay, hopefully that solved. At least Amanda's seeing a gray box. Okay, sorry about that. So the timer you will set. Oh, but now I see your chat. Oh my goodness. Well, how to troubleshoot that? I'll minimize it for now. So for setting the interval, you usually can enter in like how many minutes, and then duration. I'm sorry, that's duration, like run in 10 minutes, 15 minutes, 20 minutes. And then interval or frequency is like every day, every other day. You sort of can adjust those. There's not a magic answer for how often you should run it. There are different guidelines to use, but it does in part depend on your soil type. So as you can see in these pictures, the clay soil, if you have a lot of clay in your soil, when water is in the soil, it tends to go quite wide and spread out and not as deep, at least not as fast. Whereas on the right, sandy soil, the water just kind of goes through that really quick. And so if you know you have sandy soil, it means you might need to water more frequently, because it's going to kind of go through there. It's not going to hang out as long. Whereas clay soil, maybe you don't water quite as long or quite as frequently. And so you sort of play around with it a little bit. I'd say for like a veggie garden, maybe start with 20 minutes, maybe every other day. And then on the in-between days, just with your finger, just dig into the soil a few inches down to the root zone. And if it's damp, then it means it's on the days in between, then it means it's doing fine. The water's staying moist. If it's dry, then that means that you might need to start watering it every day. Or maybe you check just before it comes on in the morning and you notice it's still damp, then that means maybe you set it to every third day. Or maybe you run it 30 minutes, a little bit longer if it seems like it's dry. So try it out and see what works, and then it might change over the course of the summer too. Once we get really, really hot, you might need to run that more frequently. So try it out. Don't be afraid to play around with it, but just check the soil with your finger just to really get a sense on whether you need to adjust that schedule. You can do these soil jar and ribbon tests. If you Google or search for those, you'll find the instructions, but that just is a way to actually confirm what type of soil you have. Is it a lot of clay? Is it a lot of sand? And then in terms of maintenance, every year or anytime you're out in the garden, just check for leaks, see if you see any pooling or puddles or places you might have accidentally used your trowel and you made a little cut or something in it. Bring the head assembly in the winter. Clean out that filter. I have a picture here. You can see kind of got a little brown. So that was whatever was in the city water supply, but just give it a good clean out. And on the right-hand side, most of those head assembly parts have washers, that little black ring or the blue one. Those wear out over time, but those really help prevent leaks. And so if you look inside where the threading is and you see a washer, or well, if you don't see one, it means it fell out and you need to buy one, or you might see them and they start getting a little deformed and twisted. They sell replacement washers, super affordable, but just keep an eye on those washers. And then reapply that Teflon tape. I do like to do it every year around all those fittings, but you might run it each year and see if you see those leaks. And if you don't, then it's probably holding up fine. But that's just a real common source. for leaks. So troubleshooting and tips. So again, make sure you're using hose thread. When in doubt, it's less important these days because parts are more standardized, but some of the tubing and fittings, they'll all say 1/2 inch, but they're actually not the same 1/2 inch. They're slightly off. So if you can, try and buy parts from the same company, just to avoid that. Quick connects are great. An elbow hose start. So if you're working in a tight space, which on this picture you can see, I don't have a lot of room before I hit the ground. So instead of using a regular start where the tubing is, there's a like a built-in elbow there that connects to my system. And so that's just a tip that comes in handy sometimes. And what I was mentioning in the video is you want even coverage. And so on the right, all of my drip lines, the first emitter are starting like, I don't know, 8 inches from the supply line, versus on the left where I sort of intentionally have one start a little closer and then a little further away and then a little closer. And that's just based on where I make my cut. So aim for something that's staggered like the left, and you'll have fewer of these little gaps in your garden beds. This is a picture, folks were talking about raised beds, where you use 2 elbows to connect, to go up the bed and then across it. If you want it internal, then you can either just kind of put the line right underneath the frame, or you can drill a hole in the bed frame and put the elbow so that that vertical part is actually inside the bed, and then another elbow once you're in the bed to make that line across the top. That way you don't have, when you put mulch on the ground, you won't even see any of the irrigation. It won't be a trip hazard. I recommend that, but the external option is maybe just a little easier. So if you need to go under a sidewalk, you can buy a tunneling kit where you basically take your hose, you connect this little little fitting to some PVC pipe, and then a little nozzle. Kit costs a couple bucks, and you dig right where that, say, sidewalk is, and then you turn on the water, and it really is just a water jet. You make out a narrow hole underneath so you're not compromising the integrity of the sidewalk, and then you sort of force it through. It's amazing how that works. And I've read things on the internet where people say it worked for like a 7-foot driveway or something. They had to go underneath. I've tried it for sidewalks and had great success. And then when it's through, you make the PVC pipe a little bit longer than the sidewalk, and you cut off the nozzle and that hose to pipe adapter because you don't need them anymore. And then you just leave that as a sleeve in place, and you put the tubing right inside of it. So then your tubing is nice and protected under the sidewalk with a minimal amount of digging or frustration. And that's worked well for me. For containers, you can see on the left how you would run your supply line, and then you usually switch to the 1/4 inch line just because it's easier to work with. And you're using 1/4 inch supply line to go up like onto that potted plant at the top hanging there. And then once you get in the containers, when you would add your 1/4 inch drip line. And you can see in the container, you can make it with using drip line, you can have it be just cut it shorter for a real small container, or this one's a little bigger, so I do a little spiral. You can do the same thing around like a big tree or shrub. If you want to water that whole root zone, just kind of spiral around a length with the drip line. And then you can't actually really see the irrigation there, but it is there and tucked kind of toward the end. So for multiple zones where, again, you either have done your water capacity and you realize, well, I can only really water 8 beds, but I have 16, then you're going to need another zone so that you can still water them and be sure about water consistency. Or if you're watering those containers, they probably need to get watered every day because containers dry out, whereas your veggie beds, maybe they're every other day, or your containers might even be twice a day. So when you have those differences, you can't use one single system. And so you're going to have to start exploring what's called a multi-zone system. The simplest thing, if you have more than one spigot, is to do that entire setup we went through on each spigot, and you just have 2 different systems, and you can adjust the timer for each one. If you only have one spigot, you can see on the right, I have the 2 different systems, and they run on one spigot at different times. So they don't run so I have one go on at say 9 in the morning for a half hour, and then I've set the timer on the second to go on at 9:30 for a half hour. So that way I can get my entire yard watered, but not at the same time, by using 2 zones and 2 setups. There are also multi-zone timers. So in the lower left is one, you can see where there's 2 that come out of it. You either have to have a complete head assembly off of each line, meaning backflow preventer, filter, etc., that come off those ports. Or on the right, I have a 4-zone timer where that would just be kind of crazy to have 4 of all those things. And so you can put them before the timer, but then you need to buy special ones that are rated for constant pressure, because if they're before the timer, it means there's essentially always water putting pressure on them. And if they're not rated for that, they might break or not work as well. And that can start to get just more complicated. So again, that's why I would say, as much as possible, stick with, if you need a second zone, try and figure out one of these approaches. But then just know that if you're exploring multi-zone timers, you might need some specialized parts that are harder to find, but it's doable. So, so there's that. For alternatives to drip irrigation, some people hang buckets with water. Probably doesn't work as well, but it might work. Oya is old school, where you bury a ceramic pot, it leaks out. There's all sorts of things out there. Some of these actually don't work very well, some do. If you want to experiment, go ahead. Tree gators you see on usually like street sides where they planted new trees, those they just fill with water. There's holes in the bottom of the bags. Those just slowly drip water. You can buy those. Soaker hoses I talked about earlier, they also provide watering, but you never really know how much water is coming out, and you're not going to get nearly as much water at the end of the hose as the beginning. So, you know, it works, but it's not quite as efficient. If you're doing hand watering, it's worth it to get a watering wand where you can really adjust where you're watering and only water the soil, not from above. And then use mulch, use leaves, use straw, wood chips around trees. Those are all going to help with water conservation as well. So that's as much as I'm going to formally share. I will send out an email with a link you can share your feedback. I'll include, again, all the resources. We have some upcoming classes on companion planting, one that's kind of cool on making a lung defense tea, using plants as medicine, garden maintenance, what to do in the garden this time of year, and then also canning and seed saving. So some fun topics there. So it's 7:27. I want to leave plenty of time for the chat because looks like some questions have come up. So I'll start with those, but then I'll hang around past 7:30 for a little bit, just because I know there's probably a lot of things that come up. So I'm just going to scroll back and I'll take I guess I can stop sharing and see how that works. And let's see what folks are wondering about. So way back in, before I think around the video, Laura's when I do the transfer barbs and end plugs, things both stay put from the barbs. So yeah, so the 1/4-inch transfer barbs, you plug them into the line and then into the 1/2-inch line, and they're designed so they're gonna stay put. They're not gonna come out. They're like barbs that keep them from coming out. They can come loose sometimes, so you might need to keep an eye on it each year, and if it gets too loose, you can replace them or something like that. Also, a question about what brand I use. I have a bias against Rainbird because they have more specialized components, but they're a perfectly good brand. So I will either buy Dig, because that's what they carry at my local hardware store, or whatever DripWorks sells online, because they're a great company and I'll use whatever they have. Does it matter if drip lines are in parallel with garden rows? I like to have drip lines always run just in straight lines because I just know it's consistent. They don't necessarily need to match up with garden rows if you garden with rows, because in theory, the way you're setting it up, it's going to have very even soil coverage. So they really don't need to be right next to your garden rows. That said, if you're just putting in like a new transplant, little tiny plant, it's probably gonna, its roots aren't very big, so it might do a little better closer to a drip line. That's not required. There's a question, connect supply line to drip line when they're different diameters, you need a special, yeah. So if your supply line's 1/2 inch, then those 1/4 inch transfer barbs are what connect to the 1/4 inch drip line. If you were doing a 1/2 inch supply line to 1/2 inch drip line, which they make, you would just use a 1/2 inch elbow or connector. So it's really just, usually you're only going from 1/2 inch to 1/4 inch, typically. Question about mulch. Any mulch was going to work great. So in veggie beds, you don't want to use wood chips usually. So you might use straw, leaves, compost. You kind of want to keep the drip lines above all of that for the most part, just because they can get clogged and then you can look at them. In perennial areas, wood chips are great for trees and shrubs, and some people will bury the drip emitters under wood chips, and again, I'd rather see it to just check on it, but it's bulkier, so it's not going to clog it potentially as much. Question, looks like it is a heavy contraption. At the angle I'm putting puts pressure on the spigot. So yeah, connecting all this to spigots can be really tricky, and they make little things you can help to prop the whole thing up so it doesn't put too much weight on the spigot. You can even run a length of hose or tubing that starts at that, and then after you go a few feet, then you connect your head assembly. So you're sort of not setting up right at the spigot. So there are some options. And then again, about soil over the drip lines, I would keep them above for that. Okay, so I will talk more about rain barrels because I know that's come up. First of all, rain barrels only hold about, a typical rain barrel is about 50 gallons. So it's not going to be a lot of water for, depending on your garden size, I should say. The challenge with rain barrels is they are very low pressure. So unless they're elevated significantly, you're not going to get enough pressure to run most drip irrigation systems. So many people will invest in like cisterns that are just giant rain barrels and hold hundreds or thousands of gallons. And again, unless those are naturally occurring or you raise them up on a structure to get more pressure, then you have to either buy a pump, which is really complicated, or you can buy really low pressure, especially low pressure drip components and drip lines and emitters that run on significantly lower pressure than normal ones do, like 4 or 5. So it's possible, but you just need to think about, do I need to now worry about filling the rain barrel, or do I need to buy these special components? Do I need to use a pump? And all of that, I would work with a contractor or landscaper who has experience, because it gets complicated really quick to make sure you're getting the right components. So I think it's great, but it's definitely like a fairly advanced approach. And let's see, Barbara, would putting landscape fabric with mulch over and then the drip system work? So it might depend on your exact setting. In general, like if you're watering a landscape, like plants, landscape fabric is not a particularly good thing because it disrupts how water flows in soil and weeds grow on top of it, so it doesn't actually prevent weeds. So in general, we try to avoid landscape fabric. But if it's, so in that sense, I don't know that would add much, but but mulch, like wood chips for laying down the system, like your supply line. If there's a pathway, you know, you could with mulch over and then the drip system work well. Yeah, I would say mulch is always the right answer for water conservation, and it works well with drip irrigation. And let's see, a couple more. If you're thinking about this and need questions come up, you can call the garden hotline, and they or go online, gardenhotline.org, and they can provide, I think they can't recommend people, but they can give you some good resources to find people to work with, and they can answer some basic questions too. And then another question, which is good, came up about rain barrels. And not just, if you're using rain barrels, if you're collecting rainwater, is it safe? Is it a good thing to water your edibles? Because like birds poop on your roof, and there might be materials in roofing. And so the guidelines have changed over time, but for the most part, if you have your typical composite like shingles on your roof, they've done a fair bit of scientific research that shows that it's not typically gonna have contaminants that get into the foods that then affect, like have an impact on when you eat them. Just based on the way how plants take up metals and that type of thing. If you have copper roofing, that's a bad idea because it introduces copper into the environment. I'm distracted by a cute little baby. Baby drip irrigation expert in the making. And then any treated wood, if you have a roof with treated shingles or things like that, those are all, that and copper would be things to worry about. But if it's just the more common shingles you see, most people feel comfortable using that. Or the experts, many experts are comfortable recommending that, even for vegetables. If you are concerned, a rule of thumb is that root vegetables typically are going to be in more contact with soil and potential contaminants, whereas the fruit of the vegetables very often don't take up like heavy metals or things like that. It can depend on the plant and can depend on the metal, but as a general rule of thumb, if you're really concerned, maybe don't grow potatoes with that, but grow your tomatoes. But yeah. Okay, well, it's 7:36, so thanks for sticking around with all that, and good luck on your drip adventures, and let us know if you set something up, and call the garden hotline if you have more questions, and good luck. See ya.